7-dimensional space. We don't even claim we ever fill that space, but we pick some small volume of space that we care about in initial conditions to make sure we fill that, and that works. Okay, so that just takes my MATLAB line drawing approximation of our approaching airplane and takes it back into initial conditions. Sorry, from initial conditions to the goal. And it works for walking. So the story in walking, I think, is sort of natural. So I have this, this nominal limit cycle that works for the compass gate. Those are sort of, if I'm walking along, I've got small perturbations, just the nominal stability of my system can work for this. And then what I do when I'm trying to design a better controller is I start sampling initial conditions. If I find one that's outside of my funnel that I care about, if I get this, someone pushed me into this initial condition, then I just have to design a trajectory that gets me back to my nominal plane, stabilize that, add it to the tree. And the claim is you should only have to find a few of these sort of weird recovery motions, and you should be able to fill most of the space. So I think sort of intuitively it's natural for me in walking. You can do it. We're increasingly making it work. We've got a Muri project that's sort of alongside Sean's project that we're trying to do fast flight through forests now. We're doing these same computations now. If the constraints didn't become known to us until runtime, suddenly we're just told there's a tree in front of you. What do you do? The sums of squares verification I talked about is fast, but it's offline so far. So it's running on my laptop. It's not running on an embedded processor and whatever. So can we still do all this provably stable flight? Well, the answer is we've changed the funnel computation a little bit in this case so that we pre-compute verified continuous families of parameterized funnels. So we have a motion planning library now that says, okay, I can do this maneuver, I can do this maneuver, I can do this maneuver. They're all continuously parameterized and verified ahead of time. And then at runtime, you just pull from that something that satisfies the runtime constraints and goes. There's another problem, which is that not only we're trying to fly through the forest at high speed, but we have to do it with vision in the loop, right? So I have avoided vision my whole career so far, but this new Muri has got us working with vision. And take this thing, we proved all these nice theorems about stability, and then someone gives you a vision sensor in the loop, and it just breaks everything, okay, right? So vision is not nice to have in your control loop, I think. Well, it will be if Sean and everybody figures these things out, right? So this has now got a nonlinear vehicle model and perceptual uncertainty, maybe wind gusts throwing it around. Typically, if the uncertainty in the world is bounded, then we can do our robust control design and verification. Problem is, vision systems don't make bounded errors. Vision systems are going to say, sorry, I didn't see that tree, or it was a shadow, but I thought it was a tree. It's like they're going to make